Hello guys, welcome to Michsurd Academy. So in today's class on practical physics, we are going to be looking at slope and intercept analyzed with different types of graph. Okay, so in our last class we talked about the two types of graph. We can have the straight line graph or we can see the curve graph. So we have two types. One is the straight line graph and the other is the curve graph. So these two types of graph, we are going to be analyzing them today. Okay, so now we have that the slope n is normally given as the change in y all over the change in x, which is equal to y2 minus y1 all over x2 minus what? x1. So we've talked about this in our last class. So now the intercept also is defined as the value of y when x is equal to what? 0. Alright, that is the point where your line of best fit cuts the what? The y-axis. Then we have our intercept there. Alright, now for the straight line graph, we have that this formula y is equal to mx plus c. That is the equation for the straight line graph, where y, of course, this is the y-axis and this is the x-axis. M is the slope, okay, then c is the intercept. Okay, so we'll be using that equation to analyze different forms of straight line graph, how they will look like and the conditions that are imposed on them. Alright, so for the special cases of the equation of a straight line graph, let's consider this diagram here. Let's call it figure 1, okay, where we have the x-axis and we have the what? The y-axis. Alright, now we have different cases here. This is a different case. We have case 1 when the line passed through this point, and then we have case 2 when it's passed through this point. Also we have case 3, case 4, and so. Alright, so now for case 1, look up here. For case 1, we have that when c is equal to 0, then that means that this equation, if c is equal to 0, then this is out, right? So what we have is that y is equal to mx. So we have y is equal to what? Mx. So that is for the case 1. So it will be in such a way that the line will pass through the origin because there is no intercept on y-axis. It's just the intercept is actually 0. Okay, so it will pass through the origin. That is for case 1. That is where your intercept is equal to what? 0. Alright. Now for case 2, we have that the slope m is equal to 0. So if the slope m is equal to 0, that means everything here will vanish. We only have that y is equal to what? C. So therefore the equation will reduce to y is equal to what? C. So that is for case 2. So what it means is that the line will pass such a way that it will be parallel to the what? To the x-axis. You understand that? It will just be what? Parallel to the what? X-axis. Cutting the y-axis at the point C from the what? From the origin. So that is what we have for the case 2 there. Then for case 3, when m is equal to 1, that is when the slope is equal to 1, and also considering when the intercept is equal to 0. So if you look at the equation of the straight line graph, we have that the slope here is 1, okay? So here we only have x remaining, and also our c is equal to what? 0. So what it means is that y will be equal to what? X. That is for your case what? 3. So in such a way that since the intercept is 0, that means the line will pass through the origin, right? Good. And also the slope is 1. So it means that we are going to have that this line that passed through the origin here, okay, we have an angle formed with the x-axis in such a way that angle will be what? 45 degree, provided that the scaling that we choose for the x and y axis, they are equal. Okay. Now for case 4 there, we have that when we are going to look at two types here, in this case 4, when x is equal to c and is equal to 0, and also look at when y is equal to c and it's also what? Equal to what? 0. So for the first one, we have that x is equal to 0 and c is also equal to what? 0. So if we make our substitution for that, you see x is 0, right? Everything here becomes 0. Then c is also what? 0. So therefore y is just equal to what? To 0. So this will give us the equation of the x-axis. When y is equal to 0, we have the equation of the what? X-axis. So as such a way that we have the equation of the x-axis for that first case. Okay. Then the other one is when y is equal to c and equal to 0. Therefore y is 0 and c is also what? 0. So if y and c are 0, therefore our m, we have that mx is equal to 0, right? So therefore our x can be equal to what? 0 when you divide through by what? By n. So we have that x is also what? 0. So x is 0, and therefore the equation of the y-axis is what? Formed. So when the equation reduced to x equal to 0, therefore we have gotten the equation of what? Our y-axis. Alright. Then the fifth case there is when x is equal to k. This k is a sort of constant, okay? Such that if we look at the case 5 here, you see how the line passed through, okay? Such that we have a value here k from the origin, okay? We have a value here k from the origin, such that this straight line is just parallel to the y-axis, okay? So the straight line here is parallel to the y-axis. So this gives us the what? The fifth case here, that is x equal to what? K. So that's it. Now we are going to also look at how we can calculate the intercept. Okay, using this equation, we can also calculate the what? The intercept. Now let's look at an example. Okay, so at this point, we have that y is equal to mx plus c. This is the equation of a straight line graph, and also we have seen that this is the intercept, this is the slope. So if I make c the subject formula, I will have y, then mx can move over to this side, becomes negative mx. So this becomes the intercept with this what? Relation. Okay, so if I know the slope given to me, and I also know maybe a point x that is in respect to another point y. Okay, so if I should know this, I can easily what? Calculate what? My intercept. Now we already know we can just calculate our intercept directly from the what? From the graph. Okay, but now we are analyzing it with the formula and to see if we can still get the intercept from the formula. It is very what? Possible. So what you do is that you pick a point in your graph, let's say x1, y1. Okay, then you must have calculated your slope. Okay, let's say we have that the point here are 2, 3, and for our slope we got 5 as our slope. Okay, so therefore if I want to calculate the intercept will be equal to c equal to, we have that y is what? From here, if you compare, you see that your x is equal to 2 and your y is equal to what? 3. So here we are going to have that y is equal to what? 3 minus our slope here is 5, right? Then we have the x is what? Is 2. So if you do this, it will be 3 minus 10, right? That is 5 times 2 is 10. Then this will give us minus what? 7. So these are our intercepts is equal to minus 7. So if you have to draw the graph of that, you see that we are going to be considering the x-axis, I mean the negative y-axis, okay, so that in such a way that it will cut the intercept here will be on the what? The negative y-axis. So this is how we can do that to calculate for the intercepts using this equation. Okay. Now let's take another example. Maybe I have a point. Let's say we have point minus 1, 0, and our slope is giving us 4. Okay, so if we consider this equation here, we have that C is going to be y minus mx, right? So if we check this is our x and this is our y. So our x is minus 1, y is 0. So the intercept here will be 0 minus our m is giving us 4, that is the slope. Okay, then x is what? Is minus what? 1. So if we solve this will be 0 minus, this is 4 times minus 1 give us minus 4. Then because of we have a negative here, it becomes positive what? 4. So that our slope, our intercept rather, will be equal to 4. So if you are plotting the graph, you have something like this in such a way that it will cut on the what? On the x, on the positive y-axis. It will cut on the positive y-axis. Mind you, if it's a negative graph, it might be something like this. Okay, if it should be a negative graph, it will be something like this. We have already talked about the negative and we have talked about the positive graph in our last class, so you can check out that in the description link here. Okay, all right. So the next thing we are going to look at is